Okay. So maybe just a recap. I'm seeing the faces, the ones that are here, they don't seem to be following me. So, but I hope you're following. Maybe I'm wrong. Okay. So we first started with an introduction to statistics. Then we went into measure of central tendency, and we looked at the mean, mode, and median. Then we went into probability. From probability, we are now into probability distributions. In probability distributions, we look at random variables. So our random variables can either be discrete or continuous. So our random variables can be discrete or continuous. Now, for discrete random variables, these are variables that take up counting numbers. And continuous random variables are random variables that take up numbers with points or on an interval. Okay, so we first started with discrete random variables. Now, when you combine the value of the random variables together with its probability, you're just then creating a probability distribution. So a probability is just a list. A probability distribution is just a list of a random variable and its probability. Okay, so let's start with defining a particular random variable. So in this case, we have an experiment. If we toss 2 coins, okay. If we toss 2 coins, then we have the following outcome, 4 possible outcomes. We can have, okay, so we can have a tail and a tail, okay? We can have a tail and a head. We can have a head and a tail, or a head and a head. This is just, we're just listing possible outcomes when you toss 2 coins. I'm sure from these, there are no any other possible outcomes, isn't it? Are we together? So we only have 4 outcomes. We can have a head, a tail, head, a head and a tail, or a head and a head. Now, we then define our random variable. We say that let X be the event of obtaining a head. Okay, let X be the event of obtaining a head. Now, in this first outcome, when we have a tail and a tail, what will be the value of X? When we have 2 tails, when we toss 2 coins, and we have a tail and another tail, what will be the probability of X, which is the event of obtaining a head? Yes?
It will be 0 since there is no head.
So it will be a 0. And when we have a tail and a head, okay. No. Before we go any further, so before we get lost, we are here. So when we have 2 tails, our X is what? 0. Now, what is the probability of obtaining no head? What is the probability of obtaining no head? That is my question now. The X will be 0 But what will be the probability of obtaining no head? Yes?
0.25.
How did you obtain that?
I think it's because the tail in the first column there has no probability of a head at all. So let me just say 1 over, let's just say 1 over 4 equals 0.5.
Where's the 1 coming from and where is the 4 coming from?
Well, because the only column that has no head in it is the first column. And let's just say maybe that there are 4 columns here. And so I said 1 over 4 and then divided the 4 into the 1, then I got 0.5.
Okay, I can see. So there's a response here that 4 is the total of all the possible outcomes. Okay, yes. Remember, probability is is obtained by dividing the number of that particular obtaining. I mean, the probability is equal to number of events in which that particular event can occur over the total possible, all possible outcomes. So all possible outcomes, the number of all possible outcomes is 4. And the only way in which we have no head is 1. So therefore, our probability will be 1 over the total number of possible outcomes, which is 4. So it is because we only have 1 outcome in which we have no head divided by all possible outcomes, which is 4. So the probability is 1 over 4. Now, our x, in our possible outcomes, we can have 1 head. In that case, x is just 1. So what is the probability of x being 1? So for x to be 1, we have 2 events in which we have only 1 head. So that means the number of ways in which obtaining a head can occur is 2. And we divide by all possible outcomes, which is 4. So 2 over 4 gives us a 0.5, which is the probability for x to be 1. And for x to be 2, that is obtaining 2 heads, we just have 1 event. So the probability will be 1 over 4. Okay, so now if we list a random variable and its probability, then we obtain a probability distribution. So a probability distribution is just a list of all possible pairs of the random variable and its respective probability. Now, if we are using random variables which take up counting numbers, then we have a discrete probability distribution. But if our random variables take up numbers on an interval, then we obtain a continuous probability distribution. So the xi's, which are the random variables, are mutually exclusive. There is no intersection. Then since we're talking about probabilities, we still have to remember that the total probability for the random variables is supposed to be 1. And any probability should lie between 0 and 1. So I think we can see there. So you see this list that has a random variable and the probability. This box that we have here, this list, is a probability distribution, because in this list we have a random variable and its respective probability. So the list is what we call a probability distribution, and we'll say it is a discrete probability distribution because the values of the random variables are counting numbers. Now, with probability, with random variables, we also want to know the mean. So for random variables, we call the mean the expected value. Okay, the expected value. It is also called the weighted mean because for each variable you multiply the probability. Like you want to know how each probability, how each random variable affects, contributes to the mean. Okay, so the mean in general is known as the expected value. The mean is just given by the sum of the random variable multiplied by its probability. So in our previous example, the expected value of x will be obtained by summing the product of each random variable and its probability. So in this case, we have 0 multiplied by 0.25, which is its probability. Then we come to the next random variable, which is 1, multiplied by its probability, which is 0.5. Come to 2 and multiply by its probability, which is 0.25. And our expected value is 1. Okay, now again for random variables, we want to see how we can find the standard deviation. So the standard deviation is given by that formula. Again, we're going to sum the random variable. We first subtract the expected value, then we square. And after squaring, we multiply by its probability. Okay. So for our example, again, we get our random variable, subtract the expected value, we square and multiply by its probability. We are summing, so we'll add the next random variable, subtract the expected value, square, multiply by its probability. And the last random variable, 2, subtract the expected value, we square, multiply by its probability. And the standard deviation should be 0.707. So that's how we get the expected value. Yeah, the expected value of random variables. Okay, so we have a case for 2 discrete random variables, but you just need to know this. Please know, but will not do it. Yeah, will not cover it, but it is important for us to just know. So I think I just included it in assignment 1 so that you have ideas, because you are taking quantitative methods, so you have to be knowledgeable in this. So for 2 random variables, we will not do this in here. It will not be part of the assessment in the final exam. Okay, so I think this was the introduction to to random variables. So we'll now go to the in-depth of probability distributions.
Madam, you said that discrete probability is not coming in the exam, or?
I didn't say probability. I say the expected value of two discrete random variables. Expected value of two random variables. We'll just concentrate on one.
Okay.
Yes.
Thank you.
Yeah. And even the covariance, that is when you're looking at two discrete variables, will not that will not be part of the exam, but it's just important for us to know. Okay. Okay, so you can download that. So we're looking at discrete and continuous probability distributions. We have already said that a probability distribution is a list of a random variable and its its probability. So we have general cases, okay? We have general cases which we have we have named. Okay, who is we? Okay, we as statisticians. Okay. So we have the binomial distribution. This is for discrete random variables. We have the Poisson. And for continuous random variables, we have the normal distribution, and we also have the uniform and exponential. Okay, so I think that just shows the distributions. Okay, so a discrete random variable is a variable that assumes counting numbers or countable numbers or values. Okay, so if we're looking at number of complaints per day, those we are saying that they are discrete random variables because they take up counting numbers like 1, okay, you have 2 complaints, 3 complaints, or 20 complaints. Number of TVs in a household, they take up counting numbers as well. The number of rings before the phone is answered. Okay. What else can we think about? On discrete random variables. Okay, as long as we just say number, like number of children, okay, number of students, okay, so those are discrete random variables. Then there are also other variables that we say that can also be categorized as discrete, like an outcome just having 2 possible outcomes. I mean, an event having 2 possible outcomes. The outcomes can be numbered. Say gender having male and female, we can say male to be 1 and female to be 2. Then we have quantified gender. Having just 2 possible outcomes for defectiveness, say yes or no, that can also fall into discrete random variables. Okay, so we can have maybe, okay, so if you are spreading maybe peanut butter and jam, okay, something like that. So you can have one slice that has peanut butter spread first, or then peanut butter spread first, then jam, or vice versa. So those outcomes can also be categorized as discrete random variables. Now for continuous, these take numbers on an interval. Like mostly they have points. Okay, like thickness of an item, you'll find, okay, maybe this is 2 point something. Okay, temperature also takes usually takes the in point form form, like maybe 37.2, 35 point something. Height usually also in points form. So most of the variables that have points. Okay, so these are described as variables that assume any value on a continuum. Okay, so the continuous random variables take up that form. Okay, so if we are dealing with a continuous random variable, then when we list a continuous random variable together with its probability, we form a continuous probability distribution. Okay, so we have the general cases. Okay, and these are the ones that we're going to
Yes.
can't hear a thing.
Oh, that's why you are. Oh, okay.
Hello, good afternoon. Good afternoon once again.
Afternoon.
Oh, okay. So now you can get me.
Good afternoon.
Okay, cool. Let me just enable my camera. Okay, so we're talking about probability distributions. Yeah. Yeah. Okay, so it seems I cannot connect my my video. Okay, so if we can, you can get what I'm saying. I think we can proceed. Okay, so we're talking about the binomial distribution. So for a binomial distribution, this is a distribution for discrete random variables. In this distribution, we only have two possible outcomes. That is a success or a failure. So these are general cases. Whenever you have two possible outcomes, then in which there is a success or a failure, then that event follows a binomial distribution. So the probability of a success is denoted by P, a small p, and the probability of a failure is denoted by Q. And since we just have two outcomes, the probability of a success, of a failure is obtained by subtracting P from 1. Now, there are many examples or situations that we can relate to that follows the binomial distribution. Okay, so those of us, many of us have dated before, yes. So now imagine you've just started dating and you're waiting for a call, okay, from the respective person that you're dating. So if the person calls, okay, it becomes a success, okay? But if he doesn't call, then it's a failure, okay? So that event of waiting for the call, we say that it follows a binomial distribution because there are only two outcomes. It's either he calls or he doesn't call. If he calls, it's a success. And if he doesn't call, it is a failure. Now, another example, you have to, in this situation, you have to know what your success is and what your failure is. Imagine that person who might be, a person maybe in a similar context. If you don't like a particular person and maybe the person got your number, what happens if he calls? Is it going to be a success or a failure? It's going to be a failure, right? So if you don't like that person and he calls, it is a failure. Yeah. But if you like him and he calls, it is a success. So you have to define or to know what your success is or what your failure is. So in a binomial distribution, we always have two outcomes. It's either it's a success or it's a failure. The probability of a success is P, and the probability of a failure is 1 minus P, which is also equal to Q. So that's what you have to note in a binomial distribution. We will not tell you that this is a binomial distribution case. Now use the binomial distribution formula. No, we'll just narrate an event. You just have to know what the binomial distribution is and if that particular situation follows a binomial distribution or not. So in a binomial distribution, you have a failure or a success. Okay. Okay, the slides are taking quite some time. So you can download the slides. You can download the slides so that we move faster. Okay, still taking some time again. Okay, so in the next slide, I hope you have downloaded your slides. Okay. So the next slide just describes some examples. A manufacturing plant labels items as either being defective or acceptable. In that case, you just have two options. Maybe defectiveness being a failure and acceptable being a success. A marketing research firm receives survey responses of yes, I will buy, or no, I will not buy. Maybe yes, I will buy will be your success, and no, I will not is your failure. Okay, so those are some of the examples. Then we go to the next slide.
Sorry, madam.
Yes?
I just wanted to ask a question. How do you differentiate when it comes to a statement of binomial distribution and a T-diagram in a statement? A bit of a similar, so how do you differentiate?
Oh, a binomial and, okay, just a moment. Okay, so I'm back. Yeah, there was a question on how to differentiate a binomial distribution and a tree diagram. Did you say?
Yes, madam.
Okay, so it depends with the question though. Maybe if we can look at particular examples or questions, we can try and see the differences. Yeah, but maybe let's move on further to see how. Okay, maybe what I can say is that sometimes it okay, maybe what we'll do is that I'll bring out some questions on this platform so that we can discuss. Because I don't want to say something that might distract, that might give you false information. But usually you would know from the particular questions. You just have to understand what binomial is. And sometimes even the questions, the way they are phrased, you can see that you might need, if it's for a tree diagram, you might need a lot of branches, something like that. It's so cumbersome. So it's best done using a binomial distribution. But maybe we'll discuss more questions so that we can be clear on this.
Thank you.
Okay. We did the counting rules, so we'll not do them here. The combinations, I think we still remember the combinations from our calculators. Okay. Okay, so the combination, that is just a formula. So when we say n combined with x, because we're going to need this in the binomial distribution formula, so we'll be using the combination. So just hope we still remember how to do the combination. An example will be, let's have 9 combined with 9 combination 2. Are we able to get that from our calculators?
Yes.
What's the answer?
36.
Okay. Okay, are there other people who can't do that on their calculators? Is there anyone who can do that on the calculator? 9 combination or combined with 2. Okay, there's silence. Okay, so that is the formula for the binomial distribution. For a random variable that follows a binomial distribution, that is the probability of x successes in n trials with the probability of the success p on each trial. So this is the formula for probability when x follows a binomial distribution. That means it just has 2 outcomes, either a success or a failure. N will be the number of trials, x will be the number of successes, P will be the probability of a success, Q is the probability of a failure, which is also obtained by subtracting P from Q, from 1. Okay. So N is the number of trials or the sample size. So that is the formula of the probability. So the shape of the binomial depends on the value of P and N. Okay. So those are just graphs. Now we have characteristics in a binomial distribution. The mean of the random variable, which follows a binomial distribution, is obtained by multiplying our sample size by the probability of a success, which is P. So N by P gives us the mean, which is also the expected value. Okay. And the variance is obtained by multiplying N by P by Q. The standard deviation, you square N by P by Q. Now, if you find that a random variable follows a binomial distribution, and I ask you to find the mean, then you just do, or the expected value, then you just get the probability of a success and multiply by N. Then you have your mean. So see from example. So in the previous example, we had n is equal to 5 and p equal to 0.1. That means our mean or the expected value just equal to 5, which is our n, by 0.1, which is 0.5. So that will be our expected value or the mean. Then the variance, or actually this is standard deviation, is the square root of n by p by 1 minus q. And that gives us that value there. And similarly, we can do the same for the other example where n is 5 and p is 0.5. Okay, so we'll not do that here. Okay, so for the Poisson distribution, in here we have the probability of a failure or a success. But the difference of the Poisson and the binomial is that the Poisson has time in the Poisson distribution, time is put into consideration. So you want to know the probability of a failure or a success in a specified time interval. So we usually call this the average number. In the Poisson distribution, we have the average number of outcomes of interest per unit time. If in a question you find that they are telling you that maybe calls are received at a rate of 5, maybe 5 calls per minute at a call center. As long as you have the number of, say, 5 calls per minute, that is an average in a specified time interval. So then you know that the random variable follows a Poisson distribution. So we have the number of outcomes of interest, and the occurrence of one outcome does not influence the chance of another outcome. Okay, so they are independent. Okay, so you have to take note of the average. Usually, we would put the average number of something, then you just know that that question follows the Poisson distribution. Now, the average number of a particular average number of outcomes of interest per unit time is also denoted by lambda. Okay, so that is the Greek symbol there. It's lambda. The probability of an outcome of interest occurs in a given segment and is the same for all segments. Then that is the formula for the Poisson. For a random variable that follows the Poisson, the probability is obtained by that formula. That is lambda raised to the power x. E is exponential. It is there on our calculators. It's usually written e to the power x. On a Casio, it's right in yellow on the ln function. After log, there is ln. On top of ln, there is an ex. That is the exponential. So that is exponential over, this is x. X, we call that exclamation mark. In mathematics, we call it factorial. So that exclamation mark is called factorial. It is on a Casio calculator, right below shift button. You see the writing in yellow as in x factorial. Can you see that? Are you able to see the x factorial on your calculators?
Yes, madam.
There's no response.
Seen
Okay,
it.
are you able to see the x factorial on your calculator? You've seen it?
Yes. Yes.
No, madam.
Okay, so just write below shift.
We can see it.
What calculator are you using?
I'm using a sharp.
What calculator are you using?
A sharp.
Okay, so for those that are using Sharp, kindly assist, because I'm having a Casio.
It's on 4 on top of it.
So for those using Sharp, has anyone seen the factorial button or function? Those using Sharp? Has anyone seen the factorial function on a Sharp calculator? Okay, just try to look on your calculator and look for the X with an exclamation mark. That is the factorial.
Okay, thank you.
On Sharp, it shows 4. On top of 4, it's n factorial. Instead of x, it's an n.
Okay, I've seen it. Thank you.
Okay, so we have seen it, those of us using a Sharp.
Yes, we are.
Okay, so on our formula, X is that average number. That is the expected number of successes per unit time. And E is the exponential. Okay, then X is the number of successes in a segment of interest. Okay. So for Poisson distribution, the mean is actually just equal to the average number of successes per unit time. So mu, which is the expected value, is just it's equal to lambda. And the variance, again, is also equal to the average there per unit time. The standard deviation is the square root of the number of successes per unit time. So when you've been given an average that occurs per unit time and you're asked to find the mean, you just pick it the way it is, because that will also be your mean. Okay, so we have Poisson tables, but okay, maybe let's try and find that. So in this course, we'll not use the Poisson table, but we are going to find the the probabilities. So if x here, we are told to find the probability when x is 2 and lambda is 0.5. So we put that. Let's just try to put those values in our calculators and see if we can obtain that value. Let's try and put those values. 0.5 squared multiplied by e. I hope we have seen the exponential. So for the factorial, you say, after you're done, then you say divide by 2, and then that's when you press on the factorial. 2, shift factorial. So are we able to get that value?
Yes.
Okay.
0.0758, whatever. 5816332.
Yeah, it's quite a long number actually. Okay, so I said we'll not deal with the hypergeometric, but you can just study and read through on that. It will not be part of the exam. So only the binomial and Poisson. So I'll just send you questions on binomial and Poisson so that you can try them out. And for now, we'll end here. So tomorrow we'll just deal with the continuous probability distributions. So after tomorrow's lecture, we'll only have our lectures next week. Yeah, because also having lectures with in some other courses. So tomorrow we'll have a lecture on continuous probability distributions. We'll be looking at the normal. So please, from the mid assignment, I attached the normal table. So just make sure you have it because we'll be learning how to read the normal table. So we'll have our normal table, we'll learn how to read, and the normal table will be used in confidence intervals and even hypothesis testing. So we have to know how to read the normal table. Okay, so we'll end here. I'll send you questions. I'll post some questions so that you can just go through and practice. We have not done any example, but yeah, I think the review questions will be enough. You can solve them and then you can still communicate to me the answers and our advice. Okay. Okay, maybe before we go, since I've got okay, so let's have this example. It's not typed, it's not on your slides. Yeah, so that at least we just have a few of yeah. It says admissions in a hospital occur randomly at an average rate of 1.8 per hour. Admissions in a hospital occur randomly at an average rate of 1.8 per hour. What is the probability of observing 4 admissions in an hour? Okay, so admissions occur randomly at an average rate of 1.8 per hour. What is the probability of observing 4 admissions in an hour? Okay, so maybe we can just work on that. What is our lambda there? What is our lambda?
I have just a repeat of the question.
Pardon?
What
is our lambda?
Repeat of the question.
I couldn't get you.
Recap of the question. Recap on the question.
Okay, the question says admissions in a hospital occur randomly at an average rate of 1.8 admissions per hour. What is the probability of observing 4 admissions in an hour? So I was asking what our lambda is.
Lambda is
1.8.
Okay, so our lambda is 1.8, and we're asked to find what is the probability of observing 4 admissions in an hour. So we are looking for the probability that x is equal to 4, right?
Yes.
So let's replace in our formula and find the probability.
.07.
Okay, so we have an answer 0.0723.
Yes.
Yes, that is the correct answer. So in that example, you're just given the average number. You're given the admissions in the hospital. Oh, you're given that admissions in the hospital occur randomly at an average rate. So immediately you see that average rate, then you notice that it follows the binomial distribution. Okay, so I'll send more questions so that you can practice. I think we'll end here for today. Any questions?
I didn't get the answer. I was out. I was out.
The answer is, oh, okay. The answer is
0.002.
Answer is 0.0723.
Oh, 0.0723. Okay. Thank you.
So that's the answer that you should get. All right. Thank you so much. Have a lovely evening. See you tomorrow. I'll post the review question so that you practice tomorrow morning. Okay.